notes, okay, the seminar notes, yeah. So if you doesn't have the seminar notes, you can actually download it from the website. Okay, so let's look at the notes here. For salt, right? Okay, we will be doing salts today. As you know, when you got your notes, you should know that we are doing salts today. So to do salts, right, you have to do a few major parts. Okay, you have to know these 5 major parts before you can start doing questions. Okay, because usually questions they mix all these 5 things together. Okay, and the first one is the solubility of salt. Okay, so in the solubility of salt, you have to be able to tell me that whether the salt can dissolve in water or not. Okay, this is solubility. This is what we'll be going through later. Okay, 5 major parts. And then after solubility, there will be color of salt. And then we will have heating of salt, which is decomposition of salt. After that, we will have preparation of salt. And finally, the ion test. This is the 5 things that we will go through today. Okay, so first starts with the easiest part. Solubility is very important when it comes to preparation of salt. Oh no, I think the screen is lagging. Okay, oh yeah, okay, it's back. Okay, solubility is very important for preparation of salt. So you must know how to do solubility in order to do the preparation of salt later. If you can't do this part, there's no way you can do preparation of salt. And usually preparation of salt comes with a lot of bugs. Okay, like, let's see the first one. Solubility of salt. Some salts, they are soluble in water, always soluble. They are the span salt. We call them as the span. S-P-A-N. Span is sodium, potassium, ammonium nitrate. Every time you see span, confirm the salt is soluble. All right, can I? Okay, and then we look at the third one here. The carbonate, oxide, and hydroxide. The first one here, I call it as span. The third one here is COOH. COOH means when you see there is CO, carbonate, there is oxide like O, okay, there's a lot of O here, and hydroxide OH, they are insoluble. Span soluble, COOH insoluble. Clear, right? Can understand, right? Okay, then now, I will be giving you examples. So every time after I go through the notes a bit, I will give you an example. And you all have to give me the answer. Okay, like, first one. I want to know whether this salt is soluble or not. If it is soluble, you type S lah. If it is insoluble, you type I. And soluble or insoluble? Hey, very good. Malcolm and Ian, very good. Sinman. Yes, Sinman, very good. Okay. Then, next. If the example now is K2CO3, soluble or not? Okay, the answer is actually soluble. Why? Okay, you see, okay, there is K here from the span. There is also CO from the COOH. So when you got an example like this, remember, when these two groups come together, we always prioritize the first one. Okay, that means when you see span, it's straight away soluble. We don't care whether there is COOH or not. Okay, don't care. Prioritize the first group. Okay, then last. Last example. CuCO3. Soluble or not? Yeah. This one will be insoluble. Yes, very good. Okay, just like that. Okay, moving on to the last part. We have chloride and sulfate. The salts here, they are mostly soluble. Mostly soluble means most of the time they dissolve in water. So that means there is sometimes where the salt cannot dissolve in water, except for chloride salt, Cl, we call it as the roti canai. Remember? Last time we got a roti canai. Wait, the screen is lagging. Okay, we'll call it the roti canai, C for canai. Why? Because the canai Cl salt is insoluble when it pairs with persatuan. PB, Ag is agama, sorry. H is Hindu. So when it pairs with persatuan agama Hindu, the roti canai, it is insoluble. PbAgHg, persatuan agama Hindu, with chloride is insoluble. While the sulfate, we call it as a soluble. Soluble is actually a Chinese food, China food. Okay, so China food, when it pairs with persatuan bahasa Cina, it became insoluble. Is that okay? So the persatuan Cina make their own food, soluble, and the persatuan Hindu make their own food, roti canai, like that. Okay, PbBaCa, insoluble with the sulfate. PbAgHg, insoluble with the chloride. Good, can Okay. Do you have any question? If no question, can you please send me an okay? Send me an okay, then I will start giving you questions. Okay, 谢谢. Thanks for your response. 谢谢你们. Last day of holiday, right? Yeah, so sad. Okay. The first example. I want to ask the CuCl2. Soluble or insoluble? Aisha? Elisha? Malcolm? Yes. Josiah? Okay, here is soluble. Very good. Okay, this one is soluble. Okay, and then next example. How about CuSO4? CuSO4. Okay, very good. CuSO4 is also soluble, remember? Sulfate is soluble, but sometimes people will get messed up easily. They would think that, okay, the persatuan bahasa Cina is Cu, but it's not Cu. China is Ca, by the way. Okay, good. Then now, Ag2SO4, soluble or not? Okay, good. This is soluble. Nice. Because SO4 is the soluble we said just now. Soluble is not pairing with persatuan bahasa Cina. Okay, it's soluble, just like that. So usually, doing questions like this is quite easy one for students. But when the questions do it the other way around, you might face the difficulty of giving out the answer. Okay, now I want you all to give me an example of soluble salt. Now you are the one that give me example. I want an example of soluble salt but I doesn't want it to have span. I don't want to see span. Can I have one example of soluble salt without span inside? No sodium, potassium, ammonium, and nitrate. What's the example? You see, this is the difference. Just now you all can say soluble or insoluble very quickly. And now, okay, you have to think. Ian, very good. Josiah, very good. The rest of you, Malcolm, Sinman, Aisha, Alicia. Wow, Sinman one so complicated one. Okay, you can just give me any of the roti canai and siu bao actually. You see, Cl is mostly soluble. You can pair it with zinc, you can pair it with magnesium, aluminium, calcium, as long as it is not pairing with Pb, Ag, Hg. As long as it is not Pb, Ag, Hg, it can be anything. Okay, zinc, magnesium, calcium, aluminium also can. Copper also can. Okay, good. Okay, for the second question that I'm going to ask you. And for sulfate, also the same, yeah? You can give it copper 2 sulfate, magnesium sulfate, zinc sulfate, aluminium sulfate, also can. Okay, now, I want an insoluble salt without the SO42 minus or Cl minus. Simon, very good. Ian, very good. Josiah, very good. All right, Malcolm, correct, but don't forget to put a bracket, yeah? Okay. So the answer here, it can be anything carbonate, except for span. It can be copper 2 carbonate, zinc carbonate, magnesium carbonate, all this. But remember, oxide and hydroxide, yeah, guys. Oxide and hydroxide, they are actually base. They're actually base. If you see magnesium oxide is actually a base, not a salt actually. Okay, magnesium hydroxide, copper 2 hydroxide, these are all base. They are not salt. Okay. Now, it's time to go to the next part. Here. Look at the bottom. I give you all 2 minutes, I think is enough, to finish the exercise here. Try not to look at the notes. Try not to look at the notes. To make sure that the solubility can go into your brain, because it's very important for the preparation of salt later. Okay. Try not to refer to the notes. I give you 2 minutes and I start the timer here. Okay. Don't have notes. You can download it from the website, The website got. You can get it from the website. Wait, okay, 1 minute left. Okay, time's up. Finish? Yeah, okay. Ian, you finished the questions ready? Yes, okay, good. Okay, I will just put a cross for the insoluble salts, okay? So the first one is insoluble. Third one. Okay, these are the insoluble salts. The rest are all soluble. Correct me if I'm wrong, please. I just go through one time only just now. If I miss out any of the example, please let me know. Or is there any question they want me to discuss? 17, let me see. 17, we have ammonium here. Ammonium is in the span. Yeah. So it is soluble. So 17 is soluble. And that's all. Yeah. Okay. So the highlighted ones are the one they are insoluble. The rest all soluble. Any more questions? No? No. Okay. We are done with the first part. Okay, we are done with the first part. And now I think I should go to the preparation of salt first. Because I realized usually if I follow this sequence, students will come to preparation of salt, they will already forget what they learned from the solubility when it comes to preparation of salt. So I think this time I try a different way. After solubility, we do preparation first, yeah. Okay, so let us go to page number 3. Is it the next page? Yeah, just the next page, sorry. Okay, see, salt, soluble, insoluble. Soluble has 2 different methods. So this is what have to come into your mind. This is what you have to think, or this is what you have to go through when you are preparing a salt. Okay, preparation of salt, they usually like to ask you the reactants. Normally, they only ask you 2 types of questions. What are the reactants needed? 就是你要准备什么材料。Okay. And then they also ask you the method to prepare the salt. Let's say today I want to make a cheesecake. What are the ingredients that I have to first prepare? Okay, that's reactant. Ingredient is reactant. Method is you want to make a cheesecake. A cheesecake by using oven, those with oven or without oven. So there are a different method to make cheesecake. Some people they make cheesecake without using the oven. Okay, they can just put it into the fridge or something like that to get their cheesecake. But some, like maybe the burnt cheesecake, you have to put it into the oven. Okay, so different method. Okay, now see, let's say a salt like this is given. Question want me to make sodium sulfate. Give the screen some time. It's loading. Okay, the question want me to make sodium sulfate. And they ask me, hey, so what are the reactants needed to make this salt? So to find the reactant, this is what I do. I ask myself, okay, this salt is soluble or insoluble? Then you all have to give me an answer, like soluble or not. Yeah, soluble, right? Okay. So I know it is soluble, so I go like left side. This is what you have to think. This is how you think. This is how you figure out. Okay, soluble salt. Soluble salts has two methods. The first method here, it says ammonium, sodium, and potassium salt, which I call it the spa salt. Sodium, potassium, ammonium, the spa salt. No ammonium, sodium, potassium. This is the non-spa. So that means for soluble salt, you have to ask yourself further. The Na2SO4 is a soluble spa or non-spa. Does it come with spa? Got spa? Yes, spa, yeah. Okay, got spa, sodium because it got sodium. So if it is the first method, we will be using neutralization to prepare the salt. Okay, you see, this is the method. This is the method, titration. Then how do I find the reactant? Since I know that neutralization is the reaction between acid and alkali, later BM, no more BM lah. BM finished already. I mean like in May, the first week also we done BM already. If you want BM, I send you video lah. Okay, bye bye. See you tomorrow. 明天见，明天见. Okay, right? To find the reactant, I will use a crust. So when you know that the reaction is between acid and alkali, sometimes it's quite hard to relate, like, okay, oh, what acid, what is the acid has to be used? What is the alkali that has to be used? So my method is I put this thing into a crust. I split the ion, you see, ching, two ions. Oh no. First, I split them into two ions. And then, on top, I write OH, H. Acid has H+. Alkali solution can always find OH. So, you just pair them up together. Na plus and OH minus, ta-da, NaOH. H plus and SO4 2 minus, H2SO4. So this is the acid and alkaline solution I need. These are my reactants. Anyone cannot understand this part? Okay, I give you another example. I mean, sorry, you all give me another example, can I? Can I have one more example of soluble spa salt? Give me one example of soluble spa salt, and I will find you the reactants. You give me example, I give you reactant. Okay, KCl, thank you. So KCl is made up of K plus, Cl minus. Same. OHH. We get KOH, HCl. These are the reactants. When you do the equation, you get KCl. No question, right? Okay, then we do it the other way around. I give you example, you give me the reactant. Reactant is this part. Okay, so let's try. So if I want to make ammonium nitrate today, let's say, what are the two reactors needed? If I want to make ammonium nitrate, Okay, very good from Ian, Sidman, and Malcolm. The rest of you, Aisha, Elisha, Josiah, what are the reactants needed to make the salts? Okay, okay. Okay, Elisha and Aisha? Can I have the answer, please? Okay. Okay, for those who are very weak in formula, you have to know that chemical formula is the basic of chemistry. There's no way you can make improvement without knowing how to write the chemical formula. So you see, this is how serious this thing is. When you do know how to split it into ions, you won't be able to get the reactants. Okay, so good luck. Please, the chemical formula, pick it up as soon as possible. Otherwise, you won't be able to make improvement. So NH4OH and HNO3. So thanks for giving me the answer. I don't care whether your answer is correct or wrong. Thanks for always giving me the answer. Okay, next. So this is spa salts, soluble spa. Now, I give you another example that goes like this. Let's say I want to eat zinc sulfate. Zinc sulfate is a soluble or insoluble salt. Okay, nice one. From the same students again. The others, soluble or not? Faster last. Soluble, type S. Insoluble, you type IN, insoluble, in. Yes, okay, yes, soluble, good. Okay, it comes here, and hey, soluble spa or non-spa? Got spa or not? No spa, yeah, okay, no sodium, no potassium, and no ammonium. So this is non-spa. Okay, it goes down, Okay, so you can see the method of preparing non-spa salt is by making Milo, yeah. Just by making Milo, you just put the powder in with the acid, you mix, you get the salt. Not that complicated compared to the soluble spa salt. Later I will explain why. Okay, but now let us find the reactant first. Okay, so to find the reactant, same, I'm going to split the ions into two. Zn2 plus SO4 2 minus. Okay, split into two ions. And this time, our cross will be slightly similar to the left one, but it is COOH. H. That means I put another CO in front. COOH, just like the way we memorize the insoluble salt. COOH can be carbonate, it can be oxide, it can be hydroxide, just like the insoluble salt. That means it's up to you to choose whether to go for zinc oxide, you want zinc hydroxide, or you prefer zinc carbonate. It's up to you to decide. Unless they say they want zinc carbonate, then you have to use zinc carbonate. Here will be the acid. And then I believe in the notes here, you can see it says acid plus reactive metal. So my question is, can I actually use zinc to react with acid to get the zinc sulfate salt? Can I actually use the reactive metal, zinc, to react with acid? Yes or no? What do you think? Can or cannot? Yes, the answer is can, because zinc is a reactive metal. So zinc can react with the sulfuric acid to get zinc sulfate. Okay, but why I doesn't include it here? It's because sometimes when they want me to make copper 2 sulfate, let's say, okay, I draw another cross. If this time it is copper 2 sulfate, then I cannot use Cu here because Cu is not a reactive metal. So that means you have to know whether the metal is reactive or not reactive in order to use the metal itself as reactant. So my advice would be just try to avoid it. Okay, don't find trouble for yourself. You don't have to go and like, okay, reactive or not, okay. So no, you just go with the CuO, stick with CuO, will be always correct. Hydroxide, carbonate is always good enough. Okay, just like that. Easy. Okay, now you will be the one that giving me an example of soluble non-spar salt. I do want, by the way, I doesn't want sulfate, I doesn't want chloride. You have to give me a soluble non-spar salt without sulfate, without chloride. No spar, no sulfate, no chloride. One example, please. Josiah, very good. Sinwan, nice one. Ian, very good. Malcolm, nice. Yes, guys, very good. So the nitrate salt, yes, most of you use the nitrate salt. That's how you do it. Yes, very good. It can be anything nitrate, copper 2 nitrate, zinc nitrate, magnesium nitrate, your lead 2 nitrate also can. Very good. Okay, then we just pair it with the COOH. Very sleepy already. Okay. Okay, up until this part, do you have any question to ask? Is everything okay? If everything is okay, can you please tell me the okay? Yeah. Welcome, okay? Yeah. Lisha, okay? Aisha, okay? Okay. Josiah, okay? Yes. Welcome, okay? Okay, thanks. Then now, I will be telling you the difference in the method. Why the spar salt we use titration, but the non-spar we use the Milo method. Okay. It is because for soluble spar salt, the reactants, they are always exist as a solution. The reactants are all soluble. You see, ammonium is soluble because there's spar inside. And then HNO3 is also soluble. They are solution, they are liquid. So we can use titration. But then When it comes to soluble non-spar, when the first ion is not spar, no sodium, no potassium, no ammonium, you see, the substance here, the reactant here is soluble or insoluble. Without pairing with spar, they are insoluble. When my reactant is insoluble, that means they are solid. Can I put solid into the burette and do titration? Obviously cannot. So the only way I can do is like this. So you have to understand that they don't want to use the same method is because the chemical nature of the reactant is different. Some chemical, they are solid, some are solution. Solution, you can use titration. But solid, we have to use this method. Understand? Just like that. 那个材料啊 the ingredients some are solid, some are solution. Solution, we can do titration, but solid, you just put it into water, the acid like Milo, making Milo. Okay, now, drink water first. The last one. Okay, the last one here. You give me example. Can I have one example of insoluble salt, please? Okay, magnesium carbonate, thank you. Okay, that insoluble salt, same, split the ion first, always like that. Okay, wait, I split, Mg 2 plus, CO3 2 negative. This time, we're going to do N-spar. N-spar. N is nitrate. Spar is sodium, potassium, ammonium. So we can just pair them with the ions below. Magnesium nitrate. And then here it can be sodium carbonate, potassium carbonate, anything. Just like that. So the reason why I use N-spar here is because for insoluble salt, it must be double decomposition reaction. It means the reactant that you use must be a salt solution and salt solution. It has to be salt 1, salt 2. Double decomposition is mixing 2 salt solutions together to get insoluble salt. Two soluble salt to get insoluble salt. So to make sure that my reactant is always a soluble salt, that's why I use N-spar. So this one will be a soluble salt, soluble salt. Is that okay? Can I? Okay, then I will be giving you one example and you have to give me the reactant. I want to make CaSO4. Can I have the reactant, please? Very good. Good, nice one from Simon and Ian. Aisha, very good. Yes, we will be using calcium nitrate and also any potassium sulfate, sodium sulfate also can. All right, just like that. Okay, no question, right? Okay, then I think maybe you can write down the three crossed. The three cross, give me a second, yeah. Okay, the first one is OHH. The second one is COOH. And the last one is N star. Three different crosses to find the reactant. So remember, cross is for you to find reactant. Okay, now I will ask you a few questions. And after this, I will give you a short break. How? Okay, copy down the cross already. Okay, now I will be giving you random example of salts. And you have to give me one of the number here. Depends on what type of salt they are. Soluble spa, number 1. Non-spa, number 2. Insoluble salt, number 3. Okay, like first, I want BaCl2. BaCl2 should use the first cross, second cross, or third cross to find the reactants. Josiah, very good. Sinman, very good. Ian, very good. It should be number 2. Yes, Malcolm, you are right. It should be number 2. Yes. Okay, so always go like that. When you think, you go like that. Okay, you ask yourself, soluble or not? Okay, if soluble, you have to ask yourself whether it's spa or non-spa. Okay, good. This is non-spa. How about this one? AlCl3. Very good. It is also number 2. Nice one. Then how about what is that? PbSO4. Okay, good. Then last one. Last one. Normally they don't ask this lah, okay, but I just test you and see whether you know or not. Very good. It should be number 1 because potassium is soluble spa. So we will be using OHH to find the reactant. Normally, they only ask questions like this in objective, and most likely they don't ask lah. Okay. What if they want me to make this salt? What is the alkali and acid that I will be using? KOH, potassium hydroxide. And then here, do I really do this? The answer is yes. What is H2COH? H2COH is actually a carbonic acid. It's carbonic acid. It is not in your syllabus, so they don't really ask you about this. So normally you wouldn't have any chance to write carbonic acid as your answer, unless it is objective. They give you selection. Then you can do the cross and find the answer. Objective possible lah. Okay, so just telling you that this kind of example. 好了 I will be giving you 5 minutes break, and I will see you 5 minutes later, which is 2:01. Bye bye. Get up and go get some food or something, toilet. Okay, welcome back. Let's continue our class today. Okay, I think we should be able to do color and heating of salts now. So when we can do color and heating of salts, we can answer most of the questions already. Okay, so another 2 parts. Okay, color and heating very fast only. I think 10 minutes can settle lah. Okay, we look at page. Where's the color of salts? Okay, here, page number 10. For the color of salt, you have to remember that most of the Cu2 plus are blue. I think you're Form 5 now. You're Form 5 now, so I don't think this is something hard for you because you have been seeing a blue copper 2 sulfate solution, a blue copper 2 solution for many times now, especially when you are doing chapter 1 experiment. Okay, so copper 2 is always blue, except copper 2 carbonate is green and copper 2 oxide is black. Okay, the Cl here, okay, you see here, copper 2 chloride, it is green in solid state, but blue in solution. So I would say, always just remember the copper 2 chloride as a blue salt. Because normally when you see copper 2 chloride, they will be used as a solution. So that means most of the time you see CuCl2, it will be in blue color. Unless they want you to make a solid copper 2 chloride. Then in the end, the solid will be green. Understand? So I would say copper 2 carbonate green, copper 2 oxide black, the rest all blue will be easier. Fe2 plus green, Fe3 plus brown. That's all. Okay, here comes the special example. They always like to ask this in exam, especially the PDO and ZNO, because they come with 2 colors. PDO is brown when hot, yellow when cold. While the zinc oxide is yellow hot, white cold. Okay, so the way of how I remember the color is PD, you can call it as peanut, but this doesn't apply to everybody. Not everybody can accept this, but never mind, I'm just sharing with you. PD is peanut. Peanut, for me, is yellow color. I mean, with the shell, okay, it's yellow color. I think it's yellow, some light yellow color. A bit brown also, but then never mind. I just call it yellow. And then when you cook it, you fried it, or maybe you steam it or what, the color will becomes darker from yellow to brown, like the basat malam one. And of course, you think that this one, wow, cannot lah. How can you remember it like this? This method, I see like people say a color blind are you stupid method. Okay, never mind, it's okay. As long as you can remember, I don't care what method you use. So I also use another method, which is like this. Since they like to ask me CuO, PbO, and ZnO, okay, I put them into a sequence like this, okay? From A to Z, okay? The sequence of A to Z. Cu first, C first, Pb, Zn. The color, for CuO is black. There's only one black substance in the salt, CuO. CuO is the darkest color. then the opposite side must be the lightest color. The lightest color is what? White. Okay. Black. The next color group after black is brown. Color pencil. Usually another color group lah. You don't say gray lah. Okay, like gray is part of like black lah, right? So after black, it will be brown. And then another color that's similar to brown will be yellow. So from darkest to lightest, PbO is brown when hot, yellow when cold. Zinc oxide is yellow when hot, white when cold. Of course, you can also think of it as a fried chicken. Let's say today I work in KFC. KFC, the chicken, before it's being fried, it is frozen, or maybe it is coated with a layer of, I don't know what they use now, okay? But usually it'll be white color, flour or something, okay? White color. So when you start frying the chicken, hot, it turns yellow. When you're frying the chicken, it turns yellow. Longer a bit, brown. You still frying it non-stop, it's burnt black. Also can, as long as you can remember the color. That's all. For PbI2, PbI2 is yellow in color. PbI2 is yellow in color. That's all. That's all. Okay. Next, the last part, page 11. Okay, in the page 11, we have heating of salt. Okay, after this, we can do questions already. Okay, we have carbonate and nitrate salt. Carbonate salt means salt that contains carbonate ion, CO3 2 negative. Nitrate salt is the one that comes with NO3 minus. Okay, one is CO3, another is NO3. When a salt is being heated, you have to remember that this process, this reaction, will always produce metal oxide and gas. And the metal oxide is also called as residue. Residue means the remaining substance after you heat the salt. So a residue and salt. Yeah. Did I just say salt? A residue and a gas, sorry. So let's look at the carbonate salt. So everything here has carbonate. Heating a salt produces gas. Carbonate, CO3, produces CO2 gas. Okay, it looks alike, right? CO2 and CO3. So CO3 is the mother. And CO2 is the son, okay? Mother and son. CO3, CO2. So every time you see CO2, it means the salt has CO3 as well. And can you see there is only one gas, one type of gas being produced. So there are a few ways to know that the salt is carbonate. The first method is when you see they do lime water test. Lime water test is for carbon dioxide, carbonate. And then when you see only one gas, so just like I said, got two different ways, right? Lime water test or the type of gas. How many type of gas produced? One type of gas, carbonate. Then the metal oxide quite easy lah. Zinc, then zinc oxide lor. Lead 2 oxide, magnesium oxide. When we goes to nitrate, similar things happens, which is NO3. Just now CO3 produced CO2, right? Now NO3 produces NO2. And then together with O2, this one comes together with two types of gas. Okay, so what are the ways to identify nitrate salt? When you see two types of gas, nitrate. When you see NO2, then obviously the mother will be NO3 lah. Okay, why does it come with O2 as well? You can see the size of the compound for nitrate salt is usually bigger than the carbonate salt. This one, they all come with bracket too, you see? Times 2, times 2, times 2, times 2. So when a salt is being heated, it can break down into more parts. Or you just think of it this way, like NO3 is NO2, then the other two here is for oxygen, O2, like that. That's all I want to say. And before we do the exercise, you can highlight this thing, this part here, which is very important. Nitrogen dioxide gas is a brown gas. This is how you differentiate nitrogen dioxide and oxygen, because they produce two types of gas, right? Which one is nitrogen dioxide? The brown color one. Okay, so usually this part, they combine with the color of salt to test you. So for example, salt X being heated, it produces a black residue together with gas 1 and gas 2. So when you see this part, we know that the salt is carbonate or nitrate. Carbonate or nitrate. Nitrate, right? Okay. Wait, okay. Then when you see black color, black is, we only have one black substance, the CuO. So this will be Cu2 plus and NO3 minus. Just like that, copper 2 nitrate. All right, it's time to do some exercise. Finally, let us go to page. Let me see. Let's start with something easier. Page 33. Okay, what we will be doing now is we will be finding unknowns in the chart. So your job is to find me all the unknowns. So we have S, T, U, and W. Okay, no need to do the questions below. No need. Okay, don't do the questions below. You just try your best to find out all these unknown and give me the answer. Thank you. Okay, I give you one sample answer. Let's say S Yeah, something like that lah. Okay, you just let me know what is STUW. Can I have the answer, please? Yeah, set timer, 1 minute. Sinman, very good. Very good. Okay, time's up. The rest of you got 4 unknowns. You can't even find one. You can at least do 2, right? Can I have the answer, please? Malcolm. Ian. Aisha, Alicia. Josiah. Malcolm, are you here, Malcolm? Thanks, Josiah, for the answer. Malcolm, are you here? Malcolm not here. Oh, no wonder lah. He not here. Colorless gas W is copper. No. Copper is not a gas. Copper is not a gas. Copper is not a gas. So here, just now lag liao. Okay, you welcome, 来咯. Here, this is the easiest part, right? You see, okay, the difference between UW and ST is zinc carbonate, HNO3. They gave you the reactant. This one is reactant given, and you have to find the products. The way to find products, very simple. Just write the equation out. Just write the equation out. Then you will be able to get zinc nitrate. And also, they give you one H2O. What is the gas, guys? For those who haven't given me the answer yet, what is the gas? What's the gas? Okay, no, okay, Noah, okay, see, every time, okay, when we all are doing the equation, right? Okay, zinc and nitrate, we get zinc nitrate, correct or not? For the H plus and CO32 minus, remember, for H plus and CO32 minus, don't write H2CO3. You wouldn't have the chance to write this formula out actually. Okay, every time when you got this, you should split this thing into two, H2O and CO2. For this reaction, they don't combine into an acid. No, it is H2O and CO2. So the gas is carbon dioxide. And then the solution U is my zinc nitrate. Understand? Okay. So every time when they want you to find product, you write equation. Okay, then now we look at the parts on the top. Okay, you see? They want me to find the S. Solution S is a reactant or product. Solution S is reactant or product, guys. Reactant or product. Reactants, right? Do you remember just now? We did go through a part that I teach you how to find reactant. Remember or not? What is the part that we find reactant? Preparation of salt. Still remember how to do it? Okay. What is the salt that I want to prepare this time? I want to prepare zinc carbonate. You see? I want to get zinc carbonate. So I will just place this zinc carbonate into the cross. But which cross, guys? First cross, second cross, or the third cross? Zinc carbonate is the third one, insoluble, and spa. Okay, my reactant is zinc nitrate and potassium carbonate. So look at the one they gave me. Oh, they already gave me something with zinc. Zinc chloride is something with zinc. Then we can just ignore this part already. So that means solution S will be copper 2 carbonate. A copper 2 carbonate pula, potassium carbonate or sodium carbonate. Okay, once you got the reactant, they want you to find the product. Write equation, no? Write equation, this and this. You get zinc carbonate and potassium chloride. This is the answer. Any question? Find reactant, you use cross. Find product, you use equation. Can? Okay, let's try another one. Okay, we all look at you see which one easier? Which is where is the one that want to find reactant already? Let me see. Okay, page 37. Okay, I give you 2 minutes to find all the unknowns first. Once you got the answer, give me the answer. Thank you. And don't forget to read the questions, yeah? Read the questions, so that you know the information. Solution. Oh, there's solution R. Sorry. Yes, I want. Yes, please. 谢谢你. Yes, I want solution R also. It's lagging. Sorry. Hey, come on, guys. You must try to give me answer. Wrong already doesn't matter. You must try. You must try. Because you see, a question like this, like 10 marks, is a lot. And this year has a very high chance to have sorts in your essay. Like, very important sort this year for STM. Six unknown. You can find 3, you give me 3. You find 2, give me 2. Okay, very good. Josiah, can I have more, please? Thanks, Ian. Thanks, Simon. Alicia, thank you. Thanks, Malcolm. Okay, good. Okay, let's see. So according to the question, they say lime water turns cloudy. So as I told you, when you see heating of salt, how many gas here? One type of gas. When I see one type of gas, I actually already know that this is CO2. And the question just double confirm my answer, you see? Lime water cloudy. Okay. Okay, then blah 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 blah. Oh, okay, I see here. Solid white is brown when hot, yellow when cold. Brown and yellow is the one closer to the copper one, so PbO. So the salt will be PbCO3. How I know it's PbCO3? Because when I see CO2, it is CO3 2 negative ion. When I see Pb, Pb2 plus. So that's why PbCO3. Okay. Then PbCO3 plus nitric acid. I write the equation. Okay. The gas Z is actually the same as the one on top. So it will be a CO2. Here will be PbNO3 too. Okay, and then they say yellow precipitate that can dissolve in hot water. So when we see yellow precipitate, yellow color, just like I said, there's one yellow color precipitate led to iodide. Okay, so here to find the reactant for lead to iodide, I put them into the cross and I use N spa. Precipitate means like insoluble. So when I see precipitate, I know I have to use the third one, N spa. Lead to nitrate. And then here, simply lah, KINAI also can. So solution I is Ki. Just like that, done. Any question? No, okay, simple, right? Okay, let's do another one. Okay, I think we can now try easy one, this one. Okay lah, page 40. I got this from the trial paper last year. So please find me P, Q, U, Very good. Thanks everyone for the answer. You know, Kantong, when I see people spamming me with answer, happy, very happy. Okay, then I will start writing my answer now. Heat. One guess. Turns reagent U cloudy. Hiya. Of course, the lime water cloudy lah. Then, okay, you see here, MgOCO2, MgCO3. Okay, done for the top part. After that, MgO with nitric acid. Just write the equation, then you will be able to get magnesium nitrate. I believe you write your equation, it is MgNO32 plus H2O, salt and water. So just a salt solution lah. Okay. And then to get MgCO3, I put it into the cross. This is insoluble, so N-spa. Magnesium nitrate, I have it already. So I will need something like a potassium carbonate here. Very good, Ian. Sivan, okay, very good. Okay, last one. Marker, this one, N-spa, because MgCO3 is insoluble, yeah. And finally, the solution T is potassium nitrate. That's all. Can okay, one more. Next page. This time, you don't have to give me answer. Once you're done, you just type done. Okay, we have 2 done, 3 done. Okay. Lie. So this one, the question says, it is hot, brown when hot, yellow when cold. Is that okay? PbOCO2, PbNO3, PbNO3, PbCO3, NaNO3. Okay, 可以吗？ Can or cannot? Can. Is there anything you want me to discuss? Can. Okay, can. Then if can, then I think no more lor, just like that lah. Is this too hard? I don't think so. Okay, page 29. Sorry. Salt Q is lead carbonate. Let me see. Q. Oh yeah. Lead 2 carbonate. Sorry, I missed out one answer here. It is lead 2 carbonate. Sorry. Okay. Thanks. Okay, now you have to do page 29. And after this, we will go do the ion test. Okay, once you're done, okay, this time you don't have to say done. You just give me the answer for solution Y. Once you finish everything, you give me this answer, then I will know whether you finished already now. Malcolm, very good. Nice one, Malcolm. Yeah, dissolve in water lor. Dissolve in water 你没有看错 ，Yes, dissolve in water, but 你的答案错。对了 ，Yes， 对呀，对啦。The rest of you, Alicia, Aisha, Ian, Josiah, La 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 la. Hey. How? Okay lah, I cannot wait already. No more time already. Okay. So here, black is CuO. Brown gas heated two gas. I know must be something nitrate. Here got brown gas. Okay, brown gas must be NO2. NO2 always come together with O2, so salt X is copper 2 nitrate. When copper 2 nitrate is added into water, we get blue solution Y. What is blue solution Y? Copper 2 nitrate. Dissolve in water, you get back the same thing. Just like you put Milo into water. Does it turn into coffee? No, it's Milo. It's like a Milo dissolved in water. So this is salt dissolved into water. You get the salt solution. So it's the same. Okay. Then that's all. The blue precipitate here. Okay, see, this one very important. Okay, because we're going to do the ion test now. You see, add NaOH solution and also ammonia solution. And then they get blue precipitate. What is the blue precipitate actually? When I do an equation with any of the solution here, this is what I will be getting. So the blue precipitate is CuOH2. And these are the observations that you have to write for ion test. Okay, I think we should go to the ion test lah. Page number 13. Okay, to be very honest, ion test is something that you have to memorize blindly because test is a process you want to find out, you want to prove that a presence of ion or determine the presence of ion. You must follow the steps carefully and then to see whether you can get the same result or not. Okay, so here you can see there are 4 negative ions can be tested. Me, I always put them into 3 groups. Like this. Okay, why is it 3 groups like this? The one in the first group only needs 1 step to get the result. You see, just add the acid, then they got the result. Second, 2 steps, of course. You see, add nitric acid, add silver nitrate solution, 2 steps. Last column, 3 steps. Acid, iron 2 sulfate, concentrated sulfuric acid, 3 steps in total. Okay, so I remember it this way. First step for everyone is always adding acid. What kind of acid? I always go with HNO3. Except the last one has to be sulfuric acid. Okay, so first step, everybody do acid. Acid, 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 acid. Second step, for those who have second steps, we add a salt solution. To test chloride, we use persatuan agama Hindu. So we're using silver nitrate to test the chloride. To test the silver, we use persatuan bahasa Cina to test the sulfate ion. And then nitrate, we all know that it is a brown ring test. The brown comes from iron. Here we use iron 2 sulfate solution. So acid, 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 salt, salt, salt. Lastly, concentrated acid. Okay, first step no more. Okay, the second also no more. Now it's the last one, concentrated sulfuric acid. So you can see 1 step, 2 steps, 3 steps. So you must always remember the reactant. Then only you will be able to write out the sentence. Normally, they don't ask the first one. They normally ask the second and the third. Wait, the screen is lagging. Okay, the second and the third. Like that. So you have to memorize the answer. Okay. So to test the chloride ion, you see nitric acid followed by silver nitrate solution. The observation is white precipitate. White precipitate means the AgCl that is formed. The AgCl that is formed is insoluble and white color. The screen is lagging again. Yeah, okay, insoluble and white color. Okay, just like that. So the points I will just leave it for you to you, and you got to memorize yourself lah. Okay. Now for the cation test, we straight away go to page 15. Just now when we test anion, negative ion, we use acid to test. Cation is the other way around. We use alkaline solution to test, you see, OH. By the way, we just changed this part to NH4OH lah. And we also write the name ammonia solution. Okay, this table, okay, first I tell you how to do first. Okay, for copper 2, Fe2 and Fe3, you can choose whichever solution you want, NaOH or NH4OH, to test them. And of course, these are their results. The meaning of thick and cross, thick means soluble in excess. Cross means insoluble in excess. all these come with cross, yeah, by the way. We doesn't put it, it's because we put a tick, it's easier for you to identify the difference. Only this one is tick, the rest are all cross. All cross means they're insoluble in excess. So let me give you an example. Okay, the previous page, you see, to test the Cu2 plus, we actually put the answer here already. See, wait, lagging. Okay, we are going to add ammonia solution until excess. Blue precipitate is formed, and then dissolve in excess ammonia solution. Just like the table. Wait, it's lagging. Blue P, thick, and then dark blue solution. Blue P, thick, dark blue solution. Like that. That's how you write the answer. For Cu2 plus, Fe2 plus, and Fe3 plus. And then for the front part, to test the zinc, we will go down to the bottom and use this one, ammonia solution. Okay, how do we do it? Okay, we add ammonia solution until excess, and then our observation will be white precipitate is formed and dissolve in excess ammonia solution, just like that. For PB also same, you go down to the bottom like that. Okay, these are the two most commonly asked cation. The rest are all this part already. Like that lah. Okay, then next time when we have time in the class, then only we go through this one again. We will write the answer and also go through the way to memorize this. So for now, right, you just have to remember that the one that always comes in exam is nitrate. So let's say you have to memorize the ion test for exam. You go for nitrate, chloride sulfate. Then for cation, you must know the back part here. N2 plus and Pb2 plus first. A more detailed one I go through in class because we don't have enough time already. So at least today you are able to find the unknowns. Usually ion test is like the last question, maybe 2 marks or 3 marks. Most importantly is you are able to find the unknowns. Okay, so I will stop here for today and see you all next week. Bye bye. Next week, I mean for those my students, see you in class. Bye bye. Thank you everyone. Thanks for coming to the class and thanks for giving me answer. Thank you everyone. Bye bye. The video I will post it on YouTube, then you can watch it again. Bye bye. Thank you. Bye bye. 再见.